Hello everyone, this is video 14.1 looking at reflections, translations, and rotations. We're starting chapter 14, which is called the geometry of motion and change. We'll talk a little bit more about what that means here in a moment. Um, but yeah, some of the ideas from chapter 13, especially some ideas about polygons we might need. Um, but yeah, let's get started. So what this chapter is really about is about ideas of symmetry and congruence. Now, I'm going to assume that everyone's heard of symmetry at some point, and we'll see in the next section. There may be some ideas about symmetry that maybe you haven't considered up to this point. Uh, Congruence we talked about a little bit before in a very sort of loose way, but we're going to be getting into sort of a more rigorous idea of what we mean by congruence. In this section, we're going to be looking at a lot of what are called transformations. And so, what we mean by transformation in terms of geometry is we're going to take an object and we're going to do something with it. Now, that object is going to be some sort of shape. A lot of times, it'll be some sort of polygon just because it'll make things a little bit easier to see what's going on. I think a lot of the examples that I have prepared deal with triangles because it's kind of easy to see what's going on. But we're going to do something with that shape, and it will create a new shape. And that new shape is called the image shape. So we have our original shape, and then we create the image from that. So we're going to be using these two terms quite a bit over the course of this section about transformations and about images. So our first of four transformations that we're going to look at in this video deal with reflections. So this is our first one. And so you see here we've got this triangle on the left. So ABC is our original shape. And so it's going to be reflected over this line right here. So our y-axis in this case is our line of reflection. And so this is the line that we're going to be reflecting over. Now, if I were to use a different line, like if I were to use this line right here, then it would change where this image is because the distances always have to be kept. So you can see from this C to the line is 1 unit, and then this F is the image of C. This point sort of moves over here. And so this is also 1 unit. And so the A is 4 units away, and it reflects to this D, which is 4 units away. And the same thing for the B, which is 3 units, and then the E, which is 3 units. And so all these distances are preserved. Now, this object, this triangle, is not just made up of the 3 points, it's made up of these 3 line segments. And really all those line segments are made up of points also. So this point here is going to translate over here. And then again, this distance is the same as this distance. And so you can think of this as moving this line segment over, or you could think of it as moving this line segment sort of point by point. And so all of these distances have their the distance stay constant as it moves across that line of reflection. Now, a lot of the times in the book, the image is written with an apostrophe. And so to keep it kind of consistent, we could think about this as D, or we could think of this as A apostrophe or A prime, depending on the person talking. So this A becomes sort of this A with an apostrophe, and then this B would come over here and be this B with an apostrophe. So we could give these sort of like different names, and this helps a lot of times with students to see that A goes to A prime, B goes to B prime, C goes to C prime, that they match up in this way. It kind of keeps the consistency a little bit easier for some students. Our second transformation is what's called a translation. And a translation means that we're going to be moving our object along some sort of direction. Now, the book doesn't call it this, but a lot of books will refer to this as a vector. And really, a vector, you can think of it as just being some sort of arrow. So in this case, I know that everything is moving like this. So it's moving to the right 4 and down 4. And so if I take the same arrow and copy paste it, then this goes to there, this goes to there, this goes to there. So you can see that all of the 4 points in our original shape, PQRS, yet they all follow these arrows going down to here. So it's kind of the shape is sliding, it's translating. You can either think of it as sliding right 4, down 4, or sliding down at this angle, following this arrow. So this is a translation. Again, if we want, we can sort of rename these points and call this R prime because it's where R has ended up. We can call this S prime. We can call this P prime and then call this Q prime. So then the image point and the original point are using the same letters, but we're just using these little apostrophes to show that this is the image. So this is our second rigid motion, the translation. The third rigid motion we're going to look at is the rotation. And to do a rotation, we need to have two things. We need to have a center of rotation. So I have to have a point that I'm rotating around. And so this needs to be some sort of fixed point. In this case, it's 0, 0. And then we need to know the angle. Now, in this case, I'm going from ABC over here to negative A, negative B, negative C. And so I'm rotating 90 degrees counterclockwise. And so I need to know how much that I'm rotating. Now, if I was going to be rotating this 90 degrees clockwise, then I would end up with something down here. I would get this shape. And so the clockwise versus counterclockwise obviously makes a big difference as to where the shape is going to end up. I could also, if I'm so inclined, say that this is a 270 degree rotation clockwise. I could say that I'm rotating it around this way. That would work also. So there's more than one way to define what this angle is, but no matter how we define it, we should end up with the same shape either way. You might also notice that we could also sort of define this by taking this x, y, and then we can get the coordinates sort of by taking the y coordinate and taking the negative of the y coordinate and then taking the x coordinate and putting it in there. We're not going to do too much with that. We're not going to do too much about doing translations by using these coordinate points. So you might notice that sort of pattern in this example, but it's not something that we're going to be doing an awful lot with right now. The fourth rigid motion that we're going to be looking at is what's called a glide reflection. And really, it's just a combination of two motions that we've seen already. It's combining the translation, which is the glide part, and the reflection. And so the glide reflection is made up of the glide translation plus reflection, which is the reflection. And so here you can see our ABC, which is our original shape, here this little triangle. Now, one of the things that I want to point out about this is that you could do the translation and the reflection in either order. And so when you look at this, it looks like we're doing the reflection first and getting this shape, and then doing the reflection second. So, why wouldn't this be a reflection glide instead of a glide reflection? Well, it doesn't make a difference. Either of these work. So don't get too bothered by the specific order of the words. Now, as it turns out, if I did the glide first, then I would get sort of this triangle here, and then after it reflects, I get the same thing. So I'm going to get the same thing either way. And so, like I said, don't get too hung up on the order in which you do them. In order to do a glide reflection, you need all the things that you need for the two individual parts. So in order to do the glide, you need the vector. I need to know how I'm moving this shape. And then in order to do the reflection, I need the line of reflection as well. And so I need all the parts that I would need to do these two things sort of individually. These all fall under sort of this larger umbrella of rigid motions. And what we mean by a rigid motion is that after we do these transformations, the object should not change in its size, in its shape, any of the corresponding lengths, any of the corresponding angles, etc., 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 of the object. And so if you start with a triangle and you end up with a square, it's not going to be a rigid motion because it's changed shapes. At the same time, if you start with a small triangle and you end up with a big triangle, that's also not a rigid motion because even though it stayed the same shape, it changed size. Now, we're going to look at some things later on in this chapter where it will the shapes will get bigger or smaller, where it will change its size. Not so much changing shape, but the lengths and maybe even some of the angles could potentially change. For right now, though, that's not the case. And so if you look at these examples, you can see that the triangle is exactly the same shape. However, one thing that can change in doing a rigid motion, and I'll relabel these, so B prime and then C prime. One thing that can change is the clockwise order of the points. And what I mean by that is if I go A to B to C, then these letters are labeled in a clockwise direction. On the image, I go A to B to C. And so this started off clockwise and stays clockwise. The order in which we're labeling is what I'm talking about. Now here in the reflection, the A, B, and C, the original shape, they're ordered clockwise. But when I look at the reflection, the A, B, and C are ordered counterclockwise. So that can change for some transformations, but it's still rigid because the shape hasn't gotten any bigger, hasn't gotten any smaller, it hasn't changed shape or anything. The ordering has changed direction. The ordering of the vertices has changed directions, but that's okay. Don't worry an awful lot about that. And there's a decent chance if I didn't point out that a lot of a lot of you may not even notice or care. Um, this is important for something that we're not going to really talk about in this class. But I just wanted to point that out that is a change that you might see in something that's still a rigid motion. So for your checkpoint, here is a transformation. And so the question is, do you know which one this is? And how could you explain which one this is? And so after you figured out which one it is and you can explain which one it is, can you also explain how you know it's not the other three? So is there a way that you could explain how it's not the other three? So I want you to think about the example, which one is it, but also think about the counterexample. How do you know which ones it's not? As always, if you have any questions about this question or anything else from this section, bring those questions to class and we'll get them answered. All right, thanks.